Okay, let's do some factoring. Okay, for 1a, we have just the sums and products with the lead coefficient of 1. So we're looking for two numbers that multiply to negative 18 and add up to negative 3, and that gives us negative 6 and 3. So we end up with x minus 6 times x plus 3 as our factorization. Okay, for b, we now have a lead coefficient of 4, so it's a little more complicated. So now we want two numbers that multiply to negative 24 and add to 5. The negative 24 we get by multiplying 4 times negative 6, the coefficient of the x squared term times the constant. So those two turn out to be positive 8 and negative 3. So here what we do is we take this middle term 5x and we split it into 8x and negative 3x. We still have our 4x squared and we still have our negative 6. So again, these two still add up to 5x, so we haven't changed the value, we've just changed the form. What that allows us to do is now factor in pairs, and so for the first pair, we take out a 4x to get 4x times x plus 2 and minus 3 times x plus 2. So notice, because I am factoring a negative 3 out of negative 3x and negative 6, I end up with a positive x and a positive 2. I saw a lot of people making the mistake of making this an x minus 2, so you need to be careful about that. So then that gives us, when we factor out the common x plus 2, what we're left with is 4x minus 3, and that's our factorization. Just a note here, if I had reversed the order of 8x and negative 3x, it wouldn't have mattered, because the first two terms would have then factored to x times 4x minus 3, and I would have still ended up with x plus 2 times 4x minus 3. Okay, for the next one, we have 4 terms, and so we take a look, see if we can factor by grouping. These first two have nothing in common, so we'll do a little rearranging. And let's get 3ab plus 6b minus 2c minus ac. Okay, now we can factor a 3b out of the first two terms to be left with a plus 2. And now we can factor a negative c out of the last two terms, which leaves us with a 2 and a positive a. Positive a here, because we factored out a negative c, which left us with a positive a. And since 2 plus a and a plus 2 are the same, we can say we'll factor out the a plus 2, and that leaves us with 3b minus c as our factorization. Now we also could have done 3ab minus ac minus 2c plus 6b. That would have given us here a times 3b minus c, and over here we would have factored out a negative 2, which would have left us with c minus 3b, and that's just the negative, or the opposite, of 3b minus c, so we could change this to a times 3b minus c plus 2 times 3b minus c. So we replaced c minus 3b with its negative, and then we replaced negative 2 with positive 2. So now we end up with a plus 2 times 3b minus c, the exact same result we got with the other order. So it shouldn't matter what the order is, as long as you can find commonalities between the first two terms and the second two terms. All right, let's take a look at this next one here, or these next two. Okay, so right here, first thing we want to do, and this again is the first thing we always want to do, we want to see, do we have any common factors here? And we have a common factor of 3 that goes into 12, 36, and 27. And we have a common factor of x squared that goes into our x4, x to the third, and x squared terms. So what we factor out now is a 3x squared which leaves us with 4x squared minus 12x plus 9. Okay, can we factor any further? Well, inside here we have a perfect square and a perfect square, and the square roots of those are 2x and 3. And so we want to see now whether 2x times 3 doubled is equal to the middle term or the negative of the middle term. And since this gives us 6x, when we double this, we get 12x, and we can take the negative of that. And what that means is that this middle term, or this in parentheses, will factor to, we still need the 3x squared, 2x minus 3 squared. So when we multiply out 2x minus 3, we would get 4x squared minus 12x plus 9. So again, make sure you learn the factorization pattern for a perfect square trinomial, which is, let's say we have x plus a squared is equal to x squared plus 2ax plus a squared. Basically what that means is that if we know the middle, the x coefficient, we take half of it, which would be a, and square it to get this last term here. If we know the last term and the first term, we would take the square root of each, so x and a, so a times x, and double it to get the middle term. Okay, so that's a factorization pattern you should be familiar with. Okay, E, and this one might have been tough to recognize, but this is a perfect square trinomial where the 9 is equal to the square of half of the middle coefficient there of negative 6. Negative 3 squared is equal to 9. So this factors to x minus 3 squared, and now we have a difference of perfect squares. And since difference of perfect squares, a squared minus b squared factors into a minus b times a plus b, this will give us x minus 3 minus y times x minus 3 plus y. Okay, next one here, simplify this expression. Okay, what I hoped that you would see was that in the numerator here, we have a difference of perfect squares. We have 3x minus 4 squared minus 2x plus 3 squared. So we have a is equal to 3x minus 4, and b is equal to 2x plus 3. And a squared minus b squared factors into a plus b times a minus b. So that would give us 3x minus 4 plus 2x plus 3 times 3x minus 4 minus 2x plus 3. And here I need this extra set of parentheses because what I'm actually doing is I'm subtracting this entire expression here, which means I'm basically taking a negative 1 and distributing it, so I end up with 3x minus 4 plus 2x plus 2x minus, or plus 3, excuse me, and that's times 3x minus 4 minus 2x minus 3. Okay, so again, be careful about the signs here. This negative here turns everything inside the parentheses to its opposite, so it turns 2x to a negative 2x, and it turns 3 to a negative 3. Okay, now I'll combine like terms, and I'll get 5x minus 1 times x minus 7. And again, that's still being divided by 15x minus 3, which we can rewrite as 5x minus 1 times x minus 7 over 5 times x minus 3, or I'm sorry, x minus 1. These cancel out. I'm sorry, that's the wrong count. Excuse me. Let me use my little eraser here. I'm going to redo that. And what it actually is 5x minus 1 times x minus 7 over 3 times 5x minus 1. These cancel out, and I end up with x minus 7 over 3. Now, could we have done this the other way? Yes, we could have multiplied out and expanded both the 3x minus 4 squared, which would have given us 9x squared, let me seal this off here, 9x squared minus 24x plus 16, and then minus 4x squared minus 12x minus 9. So notice that we had to apply the negative to all of the terms of the expansion of 2x plus 3. This ends up giving us 5x squared, and then we combine negative 24x and negative 36x, or negative 12x to get negative 36x, and then we combine the 16 and negative 9 to get plus 7. Now this can factor because we're looking for two numbers that multiply to 5 times 7, or 35, but add to negative 36, and so that's going to give us negative 35 and negative 1, so we end up with 5x squared minus 35x minus x plus 7, which gives us 5x times x minus 7 minus 1 times x minus 7, which is equal to 5x minus 1 times x minus 7. And that's the same numerator as we got up above here, and it'll do the same canceling out when we divide it by 3 times 5x minus 1, and we'll end up therefore with, again, x minus 7 over 3. Now you can decide which of these you think is easier, but I want you to be able to at least recognize that you could have used, in this case, the difference of perfect squares. Okay, so let's move on to our next page here. Multiply out, excuse me. Okay, let's get a better size here. We're going to solve for x. So that means we want to be setting one side equal to 0 and then use factoring in the zero product property. So the first thing we'll do is we will expand on the left side, on the right side, plus 3x minus 12 equals 24 plus 8x. We will subtract 8x from both sides to get x squared minus 5x minus 12 equals 24. We'll do it again, we'll subtract again, we'll subtract 24 now. X squared minus 5x minus 36 is equal to 0. Now we want two numbers that multiply to negative 36 and add to negative 11, and that's going to give us x minus 9 times x plus 4, all equal to 0. So x is equal to negative 4 or 9. Negative 4 and 9. Okay, so we're going to factor again for the next one, but we have a lead coefficient of 3. So we're going to look for two numbers that multiply to 3 times 6 equals 18. So multiply to that and then add up to, I'm sorry, this is going to end up being a negative 6 here. I'll show you why in a second. And then numbers have to add up to 7. Okay, and the reason it's going to be negative 6 is because we subtract the 6 from both sides. We're going to get plus 7x minus 6 is equal to 0. So the two numbers then multiplying to negative 18 and adding to 7 are going to be negative 9 and 2. So we're going to split this 7x into negative 9x plus 2x minus 6 equals 0. And that should be squared. We're going to factor out the 3x and end up with x minus 3, plus we're going to factor out the 2 here, times x minus 3 gives us 3x plus 2 times x minus 3, which means that x, the solution set, is x is equal to negative 2/3, which makes the first term 0, and positive 3, which makes the second term 0. Okay, so that's solved. Let's go on to the next one here. And this one now is set up a little differently, so we have to do some rearranging before we can start to factor. And what we're going to do is we're going to cross multiply, because when two fractions are equivalent, the numerator of one times the denominator of the other is equal to the reverse, the denominator of the other times the numerator of the other. Okay, so let's do 10 times 2x minus 1 is equal to 2x plus 5 times x plus 1. This gives us 20x minus 10 is equal to, so we get 2x squared plus 5x plus another 2x is going to give us 7x, and then plus 5. Okay, so now we want to clear one side and make it that side equal to 0. So we'll subtract 20x from both sides and we'll add 10 to both sides, and we will end up with 2x squared minus 13x plus 15, and that's equal to 0. Okay, so now we need to do some factoring, and we want two numbers that multiply to 2 times 15, which is equal to 30, and add to negative 13, and that's going to give us the numbers negative 10, negative 3. That will give us 0 equals 2x squared minus 10x minus 3x minus 15, and that's going to factor into, so we'll get 0 equals, we'll factor out the 2x times x minus 5 minus 3 times x minus 5. I'm sorry, this should be a plus 15. And so that's going to give us a factorization of 2x minus 3 times x minus 5, and that means our two solutions are x is equal to 3 over 2 and x is equal to 5. Okay, completing the square. So the idea of completing the square is that we want to get our quadratic to be a perfect square trinomial so that we can then factor it into its two factors which are equal to each other, the square root of the trinomial. So in order to do that, we're going to first say, all right, I'm going to move this 2 over to the other side, so I'll add 2 to both sides. And now for here, I need a number that's equal to the half the coefficient of the x term, so that would be negative 5 over 2, and I want that squared, which is equal to 25 over 4. So I'm going to add 25 over 4 to both sides. Okay, on the left side, this is going to give me the perfect square trinomial that can be factored into x minus 5 over 2 squared. And over here, we're going to get 2, which we can write as 8 over 4 plus 25 over 4. And then that's going to equal 33 over 4. So now we have x minus 5 squared equals 33 over 4, so we'll square root both sides and we'll get x minus 5 over 2 is equal to either the positive or negative square root of 33 over 4. Because we could find, if we think about what number squared is equal to 33 over 4, well, it could be a negative number or it could be a positive number, and both would have the same absolute value. So that's why we need the plus minus sign here. So now we're going to add 5 halves to both sides, and we'll get x equals 5 halves plus or minus the square root of 33 over 4. So just further point, we can say that 5 over 2 is equal to the square root of, 5 over 2 plus or minus the square root of 33 over the square root of 4. That's equivalent, and that's equal to 5 over 2 plus or minus the square root of 33 over 2. And as a final step, we could say that that is equal to 5 plus or minus the square root of 33 all over 2. Okay. All right, so now we have another factoring or solving by completing the square, except this time the issue is we don't have a coefficient of 1 here. Well, that's easily solved. We divide through by 3 because we have an equation, so we can divide both sides by 3, and that's going to give us x squared minus 2 over 3x minus 1 over 3 is equal to 0. We're going to clear the constant by adding 1/3 to both sides. We get x squared minus 2 over 3x is equal to 1/3. So now to make this left side a perfect square trinomial, I need to take half of negative 2/3, which is negative 1/3, and square it and add that to both sides, which is going to give me x squared minus 2 over 3x plus 1 over 9 is equal to 1 over 3 plus 1 over 9. On the left side, that factors to x minus 1/3 squared. So again, notice that because this is a negative number, this is going to be minus here. And the number 1/3 is equal to the square root of 1/9, and it's also equal to half of this coefficient of x, negative 2/3. So we end up with x minus 1/3 squared equals 3 over 9 plus 1 over 9 to give them the same denominator, which is equal to 4 over 9. So now we'll square root both sides and get x minus 1/3 is equal to the square root of 4 over 9. But again, it has to be the positive or negative. But this is actually a perfect square, so we can say x minus 1/3 is equal to plus or minus 2/3, which is the square root of 4/9. Adding the 1/3, we can say x is equal to 1/3 plus or minus 2/3. And so we get 1/3 plus 2/3 is equal to 1. And we get 1/3 minus 2/3 is equal to negative 1 over 3. And so those are our two solutions, 1, negative 1/3. Okay, we are done with this page, so let's take a look at the next page. Okay, bowling ball problem. Okay, so here you're going to set up this, so let's take a look at what we have here. We're saying that this bowling ball is thrown from the top of a 490-meter building, and let's say we were graphing this and we had time down here and we had the height here. So what we're saying is that we're starting when time is equal to 0 at the top of a 490-meter building. And the height of the ball after t seconds after it's been thrown is given by this equation here. So height at t seconds, h of t, is equal to negative 4.9 t squared plus 73.5 t plus 490. And so what's going to happen is over time, first our ball is going to go up, then it's going to come down, and eventually it's going to hit the ground. And when it does, that's when the height will be equal to 0. Now, this is part of a parabola. If we were to extend the parabola like this, we would end up with a value here that would be a negative t value. That doesn't make any sense in the problem because that's backwards in time before we threw the ball from the top of the building. However, mathematically, we still would have our parabola, and basically what we'll see is that it's good to know both the negative value where our curve would hit the x-axis and the positive value, because exactly halfway between them is going to be the x value of the point when we reach our highest point above the ground. Okay, so let's factor and calculate when this will hit the ground. So this will hit the ground when h of t is equal to 0. So we set the height equal to 0. And then we can factor this, negative 4.9, and this was set up to be factorable, so we end up with t squared plus 15, actually, no, be careful, negative 15t minus 100. Okay, so that's going to give us that when we factor 0 equals negative 4.9 times t minus 20 times t plus 5, because we needed two numbers that added to negative 15 and multiplied to negative 100, and that gave us negative 20 and positive 5. We still have the negative 4.9 here, but we could in fact just cancel that out, or rather divide through by negative 4.9 because the left side is 0, so dividing by negative 4.9 isn't going to change the left side, and we end up with this. T minus 20 times t plus 5, which means that t is equal to 20 is going to be the point when it hits the ground, so 20 seconds after it's thrown. Meanwhile, this other t value over here, t is equal to negative 5, doesn't make sense in the problem because it's before the ball was thrown. It's backwards in time. But what it does help us is it helps us figure out what's this t value of this middle point here. And it has to be halfway between negative 5 and 20, which means that it has to be equal to the average of negative 5 plus 20, and that's going to equal, so we get negative 5 plus 20 is 7.5. I'm sorry, is 15, and then divided by 2 is 7.5. So when t is equal to 7.5, that's when we'll be at our maximum height. So here, t is equal to 7.5, and we just need to figure out the y value of this maximum point up here. To do that, we'll plug this t value into our original equation here, not into the equation that we got after we divided negative 4.9. That would give us an incorrect answer. So we're going to have negative 4.9 7.5 squared plus 73.5 times 7.5 plus 490. So here we'll get negative 275.625. Here we will get positive 551.25, and here we will get just the unchanged 490. And so when we add all of those together, we get, let's see here, 765.625 meters. So when t is equal to 7.5 seconds, this ball will be at its highest point here, which is the vertex of this, and the height will be 765.625 meters, what we calculated here. And again, we found the 7.5 by saying the two values that set our equation equal to 0 are t is equal to 20 and t is equal to negative 5. So we found the average, which would give us the t value halfway between them, and that gave us t is equal to 7.5, and that's what we substituted in order to figure out the maximum height there. Okay, that's a wrap.